So today we're going to talk about the chain rule. So far, we have dealt with many different types of functions, but the type of functions that we haven't dealt with yet are composite functions. So a composite function is going to be something of the form y equals f of g of x. Something like y equals the square root of, x squared plus 1 would be an example of a composite function. And the chain rule allows us to take derivatives of said functions. So what it says is that if y is equal to f of g of x, then y prime, its derivative, is going to be f prime of g of x times g prime of x. Now, this oftentimes can be a little bit confusing to kind of work with until you've done several examples. So that's what I'm going to do. I'm going to do several examples to help you out. So the first one that we're going to look at is y equals 4x squared plus 1, and I want to find y prime. So the way in which we kind of do this is that, the first thing I'm going to do, because this is a square root, is I'm going to convert it into exponential form. So remember that the square root is the same as the 1/2. So to find y prime, what we need to do is we need to find f prime of g of x and then multiply it by g prime of x. So the way I almost like to think about this is that there is a function inside of a function here. So basically there is this 4x squared plus 1 inside of this something to the 1/2. So I ask myself, well, how do I take the derivative of just the something to the 1/2 part? And if I do that, this is going to leave me with 1/2, whatever that something is, to the negative 1/2. And the key here is that whatever that something is, we're not actually going to make any changes to it. So whatever it was to begin with, that's going to be the case. So in this example, this is going to be 1/2, all of this to the negative 1/2. And then inside here is going to be just the 4x squared plus 1. Then I'm going to look at what was inside here, and I'm going to take the derivative of that and multiply it on the outside. So this is the derivative of 4x squared plus 1 is simply 8x. And then we can simplify. So if we simplify this, this will be 4x, because the 8 and the 1/2. 8 times 1/2 is 4. And then we'll write this as 4x squared plus 1 to the negative 1/2. And then if we also want to convert back into square root form, we can write it like this. Remember that when we have something to the negative 1/2, that goes in the denominator, and anything to the 1/2 power will be a square root. So let's do a couple more examples so that we can kind of see how this works with something that looks a little bit different. So if I have y equals e to the 2 sine x, again, when I want to find y prime, what I'm going to do is I'm going to remember that the goal here is that this is going to be f prime of g of x, so the derivative of the outside function, and then just keep the inside function there times g prime of x. So in this example, our outside function is just going to be e to something. So we know that when we take the derivative of e to something, it's just going to be e to that something. So this is just going to be e, and then we just keep the something, the sine 2 sine x, and then we look at what this function is here, take the derivative of that, and multiply it out here. And that is going to be 2 cosine x. So remember from last time, the derivative of sine is cosine. So this can actually be written as 2 cos x e to the 2 sine x. And it actually turns out that if y is equal to e to some function, y prime will just simply be whatever g prime of x is times e to the g of x. And sometimes this is known as the general exponential rule. So if you see this form, again, this is just the chain rule, but that is one way to kind of look at it. And then one more example here. I want to take the cosine of this stuff. So again, I think to myself, I'm taking the cosine of something. What would be its derivative once I took the derivative of that thing? Well, that's just going to be negative sine of whatever that something is. So when I take y prime here, this is going to be negative sine, and then I just keep whatever is here. I don't make any adjustments there. And then I look at the inside part. I take the derivative of the inside and then multiply it out back here. So the derivative of e to the x is just e to the x. The derivative of x squared is just 2x. And that leaves us with this final answer. One final example, we can use the chain rule twice, for example. So if I want to find the derivative of this, we would need to use the chain rule twice. So the way in which we do this is that, again, the big outside function here is going to be e to the power of something. So that's just going to be e to the sine x squared minus 2. And then I'm going to look at this thing here. And then in order to take the derivative of that, which we're going to multiply out front, we're going to use the chain rule on basically this part here. So we know that the derivative of sine is just cosine, so that's going to be cosine. Again, there's like a third inside function here, which we're just going to ignore. So that's going to be x squared minus 2. And then we're basically going to look at this and then take the derivative of that, which is just going to be 2x. So notice that we're using the chain rule multiple times because we have a function inside of a function inside of another function. So take the derivative of the outside function, and then we multiply it by the derivative of the inside function, which in turn, we do the same thing again. And again, we can write this in the most simplified form. I probably would prefer this or something along this sorts here. Maybe I'd put the cosine next to the x. That might even be easier. But yep, this is how we do that. So this is the chain rule. I hope that you found this video helpful, and as always, take care.